Okay, friends. So welcome everybody to this demo session on this course that I'm coming up with Isha Training Solutions. The course is, we call it Cloud Performance Engineering and DevOps, SRE course, Site Reliability Engineering. So we will go about, so the agenda for today's demo is going to be that we'll talk about this course. Before we talk about the course, I'll talk about the how the software has been evolved over the years, right? I'm going to just talk about that, and then we'll talk about the course, what it offers, what all we're trying to cover in this course, and how would you be able to upskill yourself using this course. This course is intended for the performance engineers, testers, cloud administrators, those who are into cloud admin, system administrators, those who are into DevOps, even the development people, those who, if you're into development, if you're into QA and trying to be into DevOps field, SRE field, this course is for them as well. Okay, so before I get started, friends, let me introduce myself. I believe you might have attended few workshop sessions with me earlier, but anyway, so my name is Roshan, friends, Roshan Kumar. I have 18 years experience, more than 18 now. I started my career as a Java developer, and then I have been into various other SUS. I have been into DevOps consultant. I have been into development as well, as I told in the beginning, and a good amount of time, 6 years of my work, I completely into performance testing and engineering. From last 8 years, I'm working as a DevOps and SRE consultant with one of the reputed giants of the world. On the cloud part, I have worked with multiple cloud, AWS, Azure, GCP, Oracle. These four cloud I have worked with. So that's background about me, friends. So this is going to be the agenda. I'm going to start with a question. We'll start with a question, and I'm going to give you a holistic view on how the software has been developed and deployed over the years, so that we understand what are we trying to discuss here. And then we'll talk about the course and your Q&A, how this will benefit you, upskill yourself, relevance in today's market where AI is taking up the lot of automation activities. We'll discuss around that. Okay, so very simple question, friends. Um, do we all think here uh, that all the software engineers that we have, irrespective of their domain, whether you are a developer, you are into a DevOps engineer, a cloud admin, or a performance tester, QA engineer, do you agree, friends, that we need to know this as per the current market, the way we are going? That do we need to know what is DevOps, what it brings to the table? Do you think we should know about microservice architecture, how different it is from monolithic applications? Uh, do you think we need to know the containers? How do we deploy applications in the containers than the VMs? Earlier, we used to deploy in the VMs, but nowadays we're deploying on the containers. Why we're discussing about Docker, Kubernetes, and the cloud part where we use as a hosting, right? We get all the infrastructure, servers, storage, and a lot of other things in the cloud. So do we all agree? So I would like everybody to use the chat option to express their views. You can mention yes, definitely, no, no idea. You can just press your thoughts, friends, on these technologies. Feel free to unmute yourself also if you want to unmute and speak about it. Definitely you can. Yes, Manoj, we have started. Okay, I see responses, start getting responses. Okay, Tirunakar and Sairam has no idea. Okay, Ankur says yes, definitely. Imran says yes, definitely, but orchestration, AI, etc++. Okay. Theo says yes. UK Singh says yes. Ayub Khan says yes, definitely. Okay. Friends, feel free to respond. If you respond, if you unmute, your mind becomes very active. So I'm going to make sure that you will have some learning today for sure. 100% mandate. I see responses from Manoj says 100% mandate to know and can add AI too as this evolution is robust. Yes, Manoj. We'll discuss on AI part. AI can be in any of these technologies can be used. Satesh says yes. Sunny says yes. Dinesh says yes. I feel these are foundations for future implementation with AI. Yes. Okay, Dinesh. So definitely, friends, okay, these are the must things know. See, I'll tell you about the AI, very buzzword, right? AI can only help you when you have the foundation knowledge. Do you all agree with me? If you don't have a foundation knowledge, can AI help you? Let's say you want to ask something using Gen AI tools. Let's say you have Copilot, Chat GPT, you want to ask something. But if you lack the fundamental knowledge, would you be able to ask right question? Would you able to drill down further?
Yeah, absolutely no, you got it.
So fundamental AI cannot replace. Understand this. AI is going to automate it. Yes, because a lot of why I'm talking about this AI thing, because a lot of people has responded AI in the response. So I just want to take it up. AI can only help you when you have the foundation knowledge. Let's say, I'll give you one example, a simple example. Let's say you don't know about a database. For example, let's say you know about MySQL database, let's say. But you don't know about something called NoSQL database. You do not have any understanding of non-relational database, let's say like MongoDB, right? Or Cassandra. You don't have any fundamental knowledge of how those things are done. What are those things? How much ever I give you Chat GPT AI tools, do you think you would be able to give me concrete, nice, exploratory answers? The one I ask about? Very difficult, right? So fundamentals has to be understood. Let's say you have to write a code in Python. Let's say I'll give you another simple example, Python. We all know that AI tools can give you the Python code, but let's say you lack fundamental knowledge, the syntaxing part. How do you debug something? Do you think if I give you the code, you'll be able to run this in the application with full confidence? For you, it'll be a fluke. Okay, I'm not sure, but I got this code. So you need fundamental knowledge, friends. So always remember that fundamental AI cannot replace, and that is what we are going to take up in this course, fundamentals. Eventually, if you have to summarize what am I going to focus in this course, or what course this course brings to you, is the fundamental knowledge in various aspects of your career. Whatever skill that you have, fundamental knowledge, I'm going to develop through this course, develop the mindset, going to lay the
Good morning.
foundation.
Good morning, Midhan.
Mhm. Anybody has any question?
Just 5 minutes back.
Okay, I'm not able to understand. We could, I'm not sure about your question. Okay, please give me some time. Okay, I'll take up the question. I'm not sure what you're asking. Is that Avinash? You want to speak something?
Sorry, by mistake. Sorry.
Okay. Okay, so friends, we are going to talk about fundamentals in this course, and that's what you would understand. That where am I focused? If you know the fundamentals, you can achieve a lot of things. Okay, so friends, we all know about. Let's come back to the original discussion. DevOps, microservices, containers, and cloud. These are the things which is definitely must know for every skill. I can just tell you few skills which may not be require this, let's say, but I cannot name. Even if I try, I can just say functional automation engineering, functional automation, right? For them, the application functionality is important. But again, nowadays, the automation engineers are the most impacted people because of automation, and they need to upskill themselves. Because I have seen, if you give the functional specifications to Copilot, let's say you don't have test cases. Let's say you submitted one functional specification document, FS document, and ask the Copilot to give you test cases. It will give you the test cases. If you upload the test case and ask them to give the automation script for in Selenium, you're gonna get the code. So friends, we have to know how can we improve? We have to upgrade ourselves using AI tools. Okay, I'll just submit at that. Okay, and let's continue. So friends, these are the things which we need to know absolutely. Why these things are important? You to understand that we should know how the software has been developed and deployed over the years. If you look at the next slide, you would understand why these things are so important. If you look at the journey, of software development and evolution, this is what you would get. Right now, we are in this phase. If I talk about DevOps, friends, earlier we had this waterfall model. Then they came the agile model, and now we are into DevOps model. If I just give you a summary, waterfall model, we developed everything we developed first, and then we started to test, and we found a lot of problems which were so expensive to fix because we were not doing incremental testing. We were not evaluating the product incrementally. That was the mistake. We developed everything, and when after spending 6 months, we completely focus on the development, 6 months to 8 months, and after the development is complete, for all the modules, for all the functionalities, we started to test. And let's say you found the issue that your application cannot scale. There is some architectural level flaw gone. So we learned from our mistakes. We moved to agile, where we took the incremental approach. We split the development into phases. We call them sprints. Sprint 1, sprint 2, sprint 3. We took into phases, and we did progressive development, testing, everything we did. We did all the SDLC steps, right? And that's how we took the feedback of the customer. Then we moved to the next sprint. Again, we did all these steps, development, testing, all sorts of testing, functional, performance, security, UAT. Again, we took the feedback from the customer. We incorporated the feedback in the next sprint. And that's how we moved upon. So agile, there is no problem with the agile, and still we use agile. But the problem right now, see, if I ask you this question, very simple question, rational question. Let's say developer is ready with the code. Developer is ready with the code. What do we eventually want to do with that code? Let's see, I would like to understand how do you think, friends? Let's say developer is ready with the code. Code is ready. What do we want? What do we want to do with that code, friends, eventually? Absolutely, Manoj. Manoj has given the right answer. Eventual goal is to take that code to production, correct? If we are using Flipkart, Amazon, we are the users, that's production. If their developer has fixed something, I would like to get that code to production for the end users like us. Yes, but we cannot take that risk, right? We take this to lower environment, we test it functionally, performance wise, security, we just do sanity, and then we release this to production. We cannot take that risk. But the process, friends, when the code was ready, okay, I request everybody to be on mute. Thank you. The process, right? When this software was ready until it deployed to production, it took a lot of time if it is done manually. Do we all agree? Think about it. Code is ready. I'm deploying the code to QA environment, and I'm doing manual steps to functionally test. And again, I'm taking the code to performance environment, doing functional performance testing, security testing. We are creating bugs. There is no automated process. There is no automated process of getting things done. Do you think it's going to take a lot of time when the code was ready and before it was deployed to production? Do you think it took a lot of time? Do you think as an organization we should try to optimize this time? If you are the owner of the company, would you take the decision that how can we make this process swift? Would you like to think about this? Friends, yes or no? Because these are the processes which could be automated. We don't want to spend so much of time in manual process, and we would like to bring in automation, and that's where DevOps comes into picture. So DevOps as a process, it's very much similar to Agile. There is no change in the process, but we have bring in automation to our SDLC process. That's what DevOps focuses on. And that's why it's so important to understand how do we create CI/CD pipeline. What are the different DevOps tools that we have? We talked about GitHub, we talked about Maven, we talked about Jenkins. Maven is the build tool, Java project management tool. Jenkins is the CI tool. We talk about Terraform, Ansible, because we want to automate stuff. I'll give you a simple example, friends. Let's say you have this website, SBI, HDFC, IRCTC. They have so many servers, right? We know that how much load Facebook, right? How much load those servers handles on a daily basis. Do you think people are creating those servers manually? Those many servers people are creating, configuring those servers manually. Do you think so? Rational thinking. I'm not asking about the whether you know it or not. Just think rationally. Is it possible to create 1,000 servers manually? Configure it manually? So we have to bring in automation wherever required. We have to bring in automation wherever required. Right? So this is we are currently living in this phase, friends, and we are talking about automation. How can we reduce the time? When the code was ready and we have to deploy the code to production, we spend a lot of time in these steps. We deploy the code to environments manually. We do various testing, functional, performance, security, UAT manually. We spend a lot of time in this process. Let's say code was ready today and I'm deploying the code after 25 days. Don't you think as an organization we should try to bring this down to 7 days or 6 days through automation? And it's possible, people are doing it, and that's what DevOps is all about. DevOps talks about bringing automation to agile process, right? Now, coming to the application architecture, friends, earlier we were developing monolithic applications. When I say monolithic applications, try to think like that you have a lot of code put together, lot of dependency in the code put together, packaged as a one unit. The problem with those monolithic code that issue with one module, issue with one function can bring the application down. If I tell you you have a Swiggy application, if I tell you whenever you order the food, Uber application or any application, when you order a cab, book a cab, you get a notification that your cab is booked, your food is ordered. If I tell you, if the notification module is not working, you would not be able to book your cab or order your food. Would you like this kind of an applications? I will simply ask why notification has to do with my order. Notification module, what has to do with my order module? Yes or no? Would you raise this concern or not with the application? We would like to make these two models independent. We don't want that module to be impacted with this module. Those are two independent units. There should not be any dependency among them. Would you like think like this? And that's what microservices focuses on, friends. Microservices, same code base, the bigger code base, huge dependent code base. We are trying to split those code base and we are creating microservices so that the applications can communicate using API calls. They don't have the code dependency as such. That's what we talk about microservices. We split the big monolithic code. Mono means single, lithic means big. We split the same monolithic code, the big code base, into smaller chunks so that they become independent of each other. Each module becomes independent of each other. So given an opportunity, friends, let's say you are trying to develop an application, which module you would choose, monolithic or microservices based architecture, where you have the less dependency of each other. You're not calling the functions. Your modules are independent. You can scale them independently. Obviously, microservices. And we are dealing with microservices nowadays. We don't have the dependency, right? Here in microservices. If I tell you, think about it. I'll just give you a simple example. Make my trip. When you go to make my trip, and let's say flights, you're trying to book a flight for your travel. You source destination date, you click on search, and what it does, make my trip, it makes the call to various flight carriers, Indigo, Air India, Air Asia. So it makes call. They have exposed their API. It makes a call, and those API respond, and they get the response in some XML, and they format it, and they display in a human readable format, which we like, right? If I tell you, if Indigo is down, Make My Trip would not be able to work. You would even Make My Trip will be down. Will you like this kind of an application? We will simply why Indigo has to do with my Make My Trip. If Indigo is down, let it be. Let Make My Trip make call to other flight carriers. So those things we are talking about, making the code less dependent of each other. Within the same application, don't have a dependency like this. If those two modules are different, serving to different functionality, deploy them separately. If microservice 1 has to call with microservice 2, call it to use API, like how Make My Trip calls Indigo. API calls. Make My Trip doesn't own Indigo database, doesn't own Indigo. They call API, they have exposed API and they call it, and that's how they get the information, and they parse it and display as the results. So we need to make the microservice architecture applications. Coming to the infrastructure part. Friends, earlier in around 1980s, when the software development started, we were deploying things on the physical server. There was no virtualization concept. VMs came later, around 2000. There was no concept of virtualization. We were deploying some tiny little application, few KBs application in the physical server, and we were wasting a lot of resources. If you check any cloud bill, right, the most costly factor in the bill is the VMs, virtual machines, the core and the RAM. The most costliest is the core and the RAM. In our laptop, the most expensive thing that we have is our core and the RAM. Don't say monitor, desktop, and all, screen. When you use a VM in the cloud, you don't get to see the screen, right? For any VM, the core and the RAM is the most costliest part. So there was no virtualization, friends, back then. So we were deploying our applications, our big monolithic applications. That time applications also used to be very small and all. So we were wasting a lot of resources. Whatever we had the application, we were wasting. So then came a virtualization around 2000. It revolutionized the utilization. It made so better the utilization that we were wasting. We were using the same infrastructure and deploying multiple applications. We could deploy 3-tier applications, multi-tier application in the VMs. You guys check your own company, where you work, how your software is deployed. Is it in the VM or is it in the container? Check this. Because I ask this question, people do not know. I feel so strange that you don't know whether your software is deployed is running in the VM or in the container. So do you know about your own company? If you have to know, you should know. It's whether it's running in the VM or it's running in the containers. No, I just know the application. I have this. Then you are not thinking through. Either it will be in the VM or in the containers, right? Good. Avinash says containers OpenShift. So Avinash uses container orchestration engine OpenShift. Good. We should know this, right, Avinash? Everybody should know this. Do we all agree? Ankur, Avinash, we all should know this. Then only we can understand things better. We can do, if you're doing performance testing, anything, right? We can size it better. We can understand, do auto scaling better. So friends, if you don't know, please check today and get yourself understand that whether you're deploying on the VM. So VM revolutionized the things than the physical server, but still, if you look at the VM utilization, CPU and the RAM, friends, we are hardly 20 to 40% utilized in the VMs. It has been observed. So in 2015, friends, there came a technology called containerization. In the same VM, we can containerize it. We can containerize it. So I'll tell you in a layman term, not everybody would know about containers, I understand. In a layman term, I'll tell you, let's say I have a 3-tier application. Let's say I have a web server, app server, and database server. Let's say I have a 3-tier application and I needed 3 VMs. In one VM, I'll run the web server, other VM, I'll run the app server, and the third VM, I'll run the database server. Let's say I needed 3 VMs to run my 3-tier application. What container can do, what container has the power that I'll take one VM and I can create 3 containers in that. And I can run web container in container 1, app container in container 2, and database container in container 3, all in the same VM. Eventually, what did we get? We were able to utilize the resources better. You could utilize the resources better. Let's say, friends, your laptop has 16 core or 8 core, 8 GB RAM, 12 GB RAM, 16 GB RAM. Depending on your infrastructure of your laptop, you can virtualize your laptop also. And you can run multiple applications. In one, you can run a Windows, in another one, you can use the Linux. So we are talking about resource utilization. You have the resource, which is in your laptop, your hardware, I'm talking about your RAM and the processor. You can use the same hardware for multiple VMs. That's what it does. Physical server has multiple cores, multiple RAM. So we use the same physical server and we create different VMs. It's the same, underlying hardware is the same. But we virtualize it and we call it VM. We can virtualize our own laptop also. And then in one VM, I can run multiple containers so that you can utilize the resources better. So we are talking, so ideally, friends, we are deploying our microservices in the containers nowadays. That's what we are doing. And that has revolutionized things. The utilization company has reported that they're able to reduce up to 60-70% of their cost. Because their VMs were not utilized, but they moved to containers. They are fully being utilized now better. That's why organization is moving towards microservice architecture and containers. The reason for it, why these things are so popular. And eventually, friends, in the cloud part, if I talk about, you need the servers. Not everybody can afford to have an on-premise data center, their own data center. Data center is a very costly affair to get. It needs billions of dollars of investment. So what we do, any startups, like all these startups, right? Swiggy, Ola, Uber, whatever you see the new companies, so many applications that have got in 5-6 years, they don't have their own data center. No, they use cloud because they can get the infrastructure, they can get the server storage, and they can leverage it. They don't have the initial overhead of billions of dollars of investment to setting up a data center. No, they use cloud, they get whatever they need, and they pay monthly bill to the cloud. Like Netflix till today doesn't have their own cloud. They use AWS. Dropbox, if you use Dropbox to upload a document, they use AWS behind the scene. Storage is from the AWS. So friends, that's why these things are so important and so relevant, irrespective of the skill that you have. Whether you are a performance tester, engineer, you are a cloud administrator, you are into QA, into DevOps engineer, into SRE engineer. If you do not have the fundamental knowledge around this, you cannot upskill. Let's say cloud, let's say I see, Roshan, how about I am doing in Jmeter and how this will help? This will make you perform cloud performance engineer. You will understand the infrastructure better, you understand the automation better, you understand how the software is deployed, how you do auto scaling. So a lot of things. So I'm going to go about the course content now, and you'll understand what we're trying to address here, the skill that we're trying to address here. Okay, you'll understand in some time. Friends, any questions on this slide? Anybody has any question? Okay, I take the silence that we're all good, friends. So friends, so this course, right? This course, I'll use a notepad. Yeah, somebody raised the hand. Go ahead, please.
Yes, sir. I have a question. So here the demo class is for two separate courses, right? Right. One is the cloud related course. Another one is the SRE course. Right.
Right.
Okay.
So we are talking about, they are very much similar. They are very much similar. This course, Cloud Performance Engineering and DevOps course that we have, and the SRE course, they are very much closely related. And that's what we have clubbed the demo of both in one. Yes, that's right. Okay, I'll talk about the course content now, friends. See, the first thing is so our entire course is designed in these four categories. Okay, you will understand this eventually. The first thing that we take up is the cloud, and we take up AWS cloud, and we understand from scratch. Okay, what I don't expect my audience to know anything. All I need is your enthusiasm and your willingness to learn new things. Because if you're learning it here, I'm going to take it from very scratch. What is cloud? Why we're talking about cloud? Why do we need cloud? What is this buzzword? Why do we call this cloud, and how different from on-prem? We'll take it from there, and I'm gonna talk about at a level where even you can try to be certified using in solution architect associate up to that level. Okay, we take up in the cloud. What I feel, let me ask you this question, friends. Let me ask this question. I need everybody to respond in the chat. In the enterprise world, right? All the applications that you see, right? Facebook, Instagram, LinkedIn, we use Ola, Uber, right? Zomato, Swiggy, we used on daily basis, right? All these applications that we use. Do you think where they are deployed, are they deployed in the Linux VM, or they're deployed in the Windows VM? Are they using underlying OS Linux or Windows? What do you think? Right? Linux. Perfect. Good. I see a lot of people. Friends, and when I ask this simple question, are you comfortable with Linux? Let's say people say, no, I'm not sure. Okay, I ask this question. You in Windows, if I give you a file, And if I ask you to search of a word and replace it, you know how to do this. Control F, Control G, and you can replace it. You know that. But if I ask you do the same thing in Linux, people struggle. I know. Okay. So I'm not sure all of you would struggle. Most of you would know that. But a lot of people in this group also, I can tell you 80% would struggle. So we, considering that, friends, I have got this feedback and we talk about Linux. We talk about Linux. We talk about how do you operate, because see, to troubleshoot, to be a SRE engineer, to be a cloud performance engineer, friends, we need to troubleshoot things. We need to somehow go inside. How do you SSH to Linux? How do you go to the Linux VM? How do you connect to Linux VM? How do you check the logs? What is the command? Because it's all command approach. How do you check the logs? How do you check the metrics? Let's see if I ask you what is the CPU, memory, disk of the host and the process. You might know about few commands, top, free, dfstat, right? SAR. We have a lot of commands to get you these details, but we should know that. How to check the logs? How do you we get comfortable with Linux? That's what my point is. So we talk about Linux here. All basics, friends. That's what you will understand. Okay, this course is all talks about basically and the most valuable thing. And at a level where you can go and troubleshoot things. You can write a shell script at a level. After going through, you can write a shell script to capture CPU memory at that level. We'll start from scratch and we'll take it from there. We talk about microservices architecture, what it is, how different it is from monolithic applications. That's what we focus on. Again, very scratch. I told you I don't expect my audience to know anything. Monolithic applications. We talk about where do we deploy? How do we create containers? We are talking about containers, right? So where do we deploy containers? How do we create containers? We talk about Docker. We talk about Kubernetes. Because again, I don't know talk about what exactly. So just know that Docker helps us to create containers and Kubernetes helps us to orchestrate auto scaling, auto healing, auto deployment. There's a lot of things which are required for production. We just cannot create containers. We have to auto scale in production when the load is there. We have to auto heal if container dies to create a new container. We should talk about a lot about orchestration. So we talk about Kubernetes and in detail, friends, in detail, not just superficial knowledge. Everything is hands-on. That's why this course is a long course. This course goes for 3 months. This course, we are gonna have 3 days a week, same time, 8 a.m. to 9 a.m., 3 days a week. Mostly it's gonna happen on Monday, Wednesday, and Friday. But if we miss any day, we'll have some other day, but we'll have 3 days a week. And we have our approximately 40 hours of live sessions. There are a few recorded sessions as well because we have a lot of content to share. Sometimes it's not possible in 40 hours to cover everything. So we share some my recorded session only. I'll tell you. Earlier used to take more time. Now we have reduced to 3 months, right? We cover, and that's what it takes time. So we talk about Docker, Kubernetes. Then we talk about DevOps. Again, everything is hands-on. I'm going to show you how do you create CI/CD pipeline. How do you install Jenkins? How do you connect to the Linux server? How do you create pipeline using Jenkins file, Maven? I'll talk about those things in DevOps. How do you do continuous performance testing in DevOps? How do you create Jmeter job and run Jmeter in the Jenkins mode so that you don't have to go to open the Jmeter and click on run. You can do using non-GUI mode and runs on the remote machine. Right? Continuous performance testing in DevOps. CI/CD pipeline. That's what I would put it. We talk about database, friend, cloud databases. We know about databases, but cloud databases offers a lot because it has, see, cloud is all about automation. Cloud has made things simple. Earlier, if you recall, friends, let's say if I take you 15 years back or 10 years back, there used to be DBA role, Oracle DBA, this DBA, that. Are you finding these jobs nowadays? A lot of such roles. We used to get Linux admin, system admin. We used to get those kind of roles. Are you finding these kind of jobs nowadays? You will not see such roles because those roles have gone to DevOps. They have upskilled themselves because cloud has automated things. Nowadays, to create a database, I don't need an expert. I can just click few things and I can create a database in the cloud. And cloud has automated this. The installation process, storage auto scaling process, taking a snapshot, creating a read replica, high availability, all these things are automated. I don't need to do anything. I don't need expert. I just need an expert to do a SQL tuning, which a performance engineers or developers are expected. I need only that. Indexing, SQL tuning. Yes, if I'm having a huge database, yes, DB is required. But for small, simple websites, simple applications, you don't need a database expert, DB as expert. So we talk about cloud databases. We talk about observability in this course, friends. How do you do monitoring and analysis? We talk about monitoring part. We talk about Prometheus and Grafana. And Elastic Stack. We talk about automation here, which is very much required for the SRE engineers. We talk about automation. Automation using Terraform, Ansible. Right. So I'm going to take you to the link, friends. Now, this is what at the high level we cover. One thing very important, we talk about Java performance engineering. How do you troubleshoot Java applications? If you have an issue, how do you troubleshoot it? If you have an issue on the memory management, GC algorithms, how do you decide whether to go with G1 GC or parallel GC, CMS, GC log analysis, heap dump analysis, thread dump analysis? We talk about that to troubleshoot Java applications. Right? So this is the high level, friends, we cover much more. Okay. Because I am not going to detail, I have not detailed what we cover in cloud. I'm going to give you a link, friends. I'm going to give you a link. Same content is for the cloud performance engineering in DevOps. Only difference that Java programming is important for the cloud performance engineering, and here Python. SRE. For SRE, friends, Python is the most suitable language that you should be comfortable with for scripting part. And if you want to see yourself as Java performance engineering, Java programming would be helpful because nowadays enterprise application Java Spring Boot is being used, right? So we are not moving away from Java. So if you know the programming language, you can help us better understand the problem, talk to developers better, right? So friends, we are gonna meet 8 a.m. to 9 a.m. 3 days a week, mostly Monday, Wednesday, and Friday. Today is Wednesday. We'll meet next on Friday. Okay, that's going to be our day one. Today our demo session. We're going to day one on the Friday. And if you look at the detail, AWS, friends, what all we cover in AWS, these are all things we cover in AWS. Again, I don't want to go in detail, but just know it's enough for you whatever you're required to know as a cloud performance engineer or an SRE engineer or a DevOps engineer, cloud administrator, support role. It's much more than enough. I'm going to prepare you for the Solution Architect Associate certification, SAC03, at that level, friends. We talked about Linux. Again, a lot of content. We talk about SRE concepts. I'll just put that here. SRE concepts. What is SLOs? What is high availability? What is your understanding of high availability? What is your understanding of reliability, fault tolerance, disaster recovery, change management, incident management, chaos testing? Right? We'll discuss about that. Again, the monolithic application microservice architecture. Yeah, Abhinav, I'll come to your question. Just give me a few minutes. I just need to complete this part. Please focus right now on the course part. I'll take up all the questions. Microservice architecture, Docker, Kubernetes, detail, auto scaling in containers, ingress. And we using EKS, friends, Elastic Kubernetes Engine. We have this AWS service. DevOps part, what all we cover is here. Gaining resiliency and reliability in AWS. Using AWS services, how would you make sure your application is highly available, reliable? We talk about that. Observability, Linux monitoring as part of the Linux part, CloudWatch as part of the AWS part, and two more, Prometheus, Grafana, and Elastic Stack. Java performance engineering and automation using Terraform and Ansible. And friends, we share some Python. This is not my recorded sessions. I'm going to test these are going to be recording sessions. Python. Somebody very good at Isha Training Solutions. Python recording sessions. We have it, right? And we can also share the Java part as well. Okay, but yeah, as I told you, for SRE, Python is going to be more suitable for scripting part. And if you are looking for a Java cloud performance engineering, Java is most preferred part. So you can choose any one of them as per your requirement. So that's what we cover, friends. Okay, that's what we cover. The sequence would be this, that first we talk about cloud, and I'm going to give you the recorded session here. This is going to be my recorded session. Basics, because we cover basics, friends, right? We cover the basics. This is the recorded session that we provide. And Java performance engineering. These are two recorded sessions. And again, going to be my recorded session. And apart from that, everything is hands-on. The cloud, microservices, Docker, Kubernetes, DevOps, databases, observability, automation, SRE concepts, all are the live sessions. Okay, these two are going to be recorded sessions. My recording, so you can ask questions anytime, right? So I'll just show you, friends, how it looks like. Okay, meanwhile, Avinash, please go ahead. I think you have asked a question. Avinash and one more person. Yeah, Ankur is the first person to raise the hand. Please go ahead, Ankur and Avinash, go ahead. Ask your question.
Actually, I already asked. It's an old hand. So.
Okay. Avinash, go ahead.
Yeah, hi Rano, good morning. First of all, my question was that this course is for Java performance engineer or SRE or both?
Both. See, I'll tell you, for a Java performance engineering, when I say what is the skill we are looking for? We are looking for the skill that I'm going to assume that you already know some Jmeter or any performance testing tool. You know about performance testing. When I say cloud Java performance engineer, you should know about cloud part, how applications are being deployed in containers, Automation is required for everybody nowadays. You should know about anyway, you should know about observability, right? And we are going to share the Java performance engineering. So this course is very much is for both. We target, so if you look at this, primarily we target these two skills. Performance engineer trying to be a cloud performance engineer and upskill themselves. That's one thing. Second, the SRE professionals. If you are in some other domain like DevOps, you are into cloud admin, you are into support role, and you're looking towards how to become an SRE engineer, right? And we focus on that as well, with so many other concepts that you require. So both the skill sets, even if you look at in general also, the skill sets match. Up to 70% the skill set match. For the SRE engineers, the automation becomes the additional skill, more automation using Terraform, using CI/CD pipeline, right? So these things becomes additional skill for the SRE engineers, the Python scripting. So they need to focus on these additional skills, this 30% I'm talking about. So that's where the difference is. But apart from that, 70%, even if you check any job description, 70% you would match the skill set of a Java performance engineer versus a SRE engineer. I hope you
So
got.
this course is, I mean, DevOps. How much does it differ from DevOps?
Everything
Or
is. Go ahead.
I mean, everything is DevOps, but if it is very specific to DevOps, what are the other areas that you think we need to cover?
You are asking from a DevOps perspective?
Yeah.
See, as a DevOps engineer, you need to be more, see, as part of this, see, whatever we are covering here, a DevOps engineer should know that, first of all. Secondly, what additional they need to have is the hands-on experience. Again, DevOps, see, there are three skills. Performance engineering. I would put Java performance engineering. Cloud Java, I would say this. Cloud performance engineering. DevOps professionals. And SRE. DevOps engineers or SRE engineers, okay? So if you look at the difference here, I'll tell you the difference. These cloud performance engineering focus on the load part, load aspect in lower environment. They don't focus on in the prod environment. They focus on the QA environment or performance environment. They do the load testing, but they should have the knowledge of the cloud to check whether auto-scaling is working or not, Docker, Kubernetes, Ansible. So they need to have the skill. So the main focus is on the load part. When you load test the application, how is your performance looks like, so that we can be sure that in production, if this code get deployed, will be all right, right? And it should meet everything. So that's the main focus here. But you should know the cloud part. If you don't know the cloud part, how Docker Kubernetes works, again, how the automation works, very difficult to get this skill. DevOps engineer, their main focus is on the deployment. Main focus. DevOps developers have developed the code. DevOps engineer main focus is to deploy the code to various environment. So they need to focus on here the deployment part. Deployment here, the load testing, performance testing, right? And in the cloud aspect, so we are talking about the cloud deployment part. So you need the knowledge on the Jenkins, one of the very CI tool which you can use automate CI/CD pipeline. You need to have a thorough understanding on the Maven, how your application is being deployed, whether it's a VM or it's contained. Let's say it's deployed on Kubernetes and you don't know Kubernetes, then how are you going to deploy things? If it's a VM, if it's let's say Tomcat server, if you don't know about Tomcat, you cannot deploy things. So DevOps skill is mostly on your application being deployed. You should be comfortable with the technology you are deploying. Let's say they're deploying about databases in the cloud. If you don't know what is the database, how to deploy, you cannot deploy things. So you need to upskill. DevOps needs to upskill based on the technology they are working on, the application part you're working on. So they need to know that main focus is on the deployment and automation. Their main focus is on this. And then SRE part is all about production reliability. They are responsible to make sure production is highly available, reliable, secure, fault tolerant. So these, and they are very good at troubleshooting. They need to be very good at troubleshooting, which is a very, very important skill for a performance engineer also. Let's say if I ask performance engineers, let's say your response time is, it used to be 400, 300 milliseconds. Now it has gone to 2 seconds. How would you troubleshoot this application? How would you narrow down the problem? You need to have, even the cloud performance engineers should have the skill. They should understand the cloud aspect. They should understand a lot of things. Even the SRE engineer has to have that skill, troubleshooting experience, troubleshooting skill. So, and in production, that is the difference between these three guys. So totally very much overlapping skills they have, but they have a distinct function also as well to perform. But the troubleshooting skill is here also required. If a performance engineer, friends, doesn't know how to troubleshoot the performance issues, problem. In the production, your SRE engineer role is to make sure production is highly available, reliable, and you do not have the skill of troubleshooting experience, then how would you know where the problem, right? That is the key difference between a cloud performance engineer, DevOps engineer, and SRE engineers, friends. And we are focusing on these aspects, the fundamental part, which is required for all the skills. Fundamental knowledge, the foundation part is where we are focusing on. As I told in the beginning, all these things are required for all these three skills. And we are focusing on the fundamental part. And eventually, we will talk about AI perspective. How do you use AI to upskill, to explore? Once you have the fundamental knowledge built, let's say you don't know Kubernetes, then how would you use AI? If you don't know Docker, how would you use? If you don't know Terraform, how do you use AI? So once you have the fundamental knowledge, you can use those AI skills in any of these skills. AI for any of these skills. You should have the fundamental knowledge, friends. So I'm going to focus on the fundamental knowledge, making your foundation so strong that whether you join as an SRE engineer, you need to have some, you need to have some background knowledge, right? We are not talking about that. I'm talking about freshers. Freshers have to choose one skill and they need to focus on. If you want to be a performance tester engineer in this domain, you should have a performance testing tool knowledge as well. Okay. If you want to be a DevOps engineer, you should focus on the different aspects. You should know about Tomcat. You should know about databases, few databases in general. If you want to be an SRE engineer, and let's say you are into support role, I'm going to guide you on this. So all these skills that you require, and then depending on the AI, will use the AI to upskill yourself. Right? I hope, am I clear, friends, all of you? Am I making sense?
Thank you.
Sure. I am getting a question. What are the possible job roles after this course? As I told you, Imran, you are, what's your background, Imran? If you want me to ask specific question, what's your background, Imran? What current role? So that I can guide you. Exactly. Yes. Yes, Manoj, you have a question. Go ahead.
Yeah, hi. Thanks, Roshan.
Sure.
Well, I think firstly, this is very comprehensive course content I've come across, combining various roles like you explained, performance engineering, DevOps, and SRE stuff. So That really looks good. Thanks for that. The questions I have is one is definitely around the observability. So I know you're covering pretty much Prometheus, Grafana, or CloudWatch from AWS or the Elastic Stack, but when you say hands-on, how are we going to implement this? Like, do we, let's say, for example, Elastic Stack for passing the logs and monitoring the logs and stuff. So are we going to have any available dumps and we'll be passing those logs, or do we have any applications we'll be playing with a live application and looking at the logs of that application? How are we going to implement it?
Sure. So we are going to, first of all, on the hands-on part, we'll understand, since you talked about Elastic Stack. So we are going to first understand what is Elastic Stack architecture. Right? We have Elasticsearch, Kibana, Logstacks, and other beats that we call it, right? So we'll talk about that first. We are going to create our own VM or own virtual machine, and we're going to install things. When I say hands-on, we are going to set up Elastic Stack. I'm going to install, you will see me installing Elasticsearch. You will see me installing Kibana. You will see me installing Beats. You will see me using Kibana, getting the Kibana up and running live, right? In my own server, Kibana up and running. And then we are going to install the Beats, the agent, which collects the metrics. So I'm going to use the same VM, or I can use a different VM to capture the metrics from the, let's say, Linux. I would like to capture the Linux metrics or the logs of the Linux. You can deploy application there also if you want some web application. I will tell you web application in the very first phase itself in the cloud part, how to install a web application. So the point here is that I'm going to install all the three layers, Elasticsearch, Kibana, and the Beats. We will see the dashboards being created, the logs being generated, right? We will see this in the live Kibana dashboard.
Okay, yep. Thanks for that. But do we also expand creating alerts and stuff? Because I believe when we try to implement this or apply whatever the learnings that are coming out of this course into our job roles, uh, there is an expectation that we also need to maintain the dashboards, create the dashboards, creating alerts and stuff.
Sure. So we do talk about dashboard and alert creation. Yes.
Thanks.
Couple of demos, right? Couple of demos. How do you go about setting up alerts in your Grafana dashboard as well in the Kibana dashboards? Yes. So same thing for Prometheus and Grafana also. We'll have a dashboard in Grafana. Using Prometheus is a database. So we will get the details from the database. Using the same, I'm going to install the same Prometheus and Grafana in one of our own VM. And we're going to see the dashboard, real dashboards, and alerting. How do we go about setting up alerts in Grafana and Kibana both? Yes.
Thanks.
Will you also talk about Splunk? Sorry.
Go ahead, complete your question first, Manoj. Yeah, let Manoj complete. We'll talk about Splunk. I got your question. Please, Manoj, please complete your question.
Just on the observability tools, like are we expanding that to integration with the Jmeter or any performance tool, or is it not covered here?
No, integration part, see, when we say observability, we would like to integrate with the application, right? My web server, my app server, my database server, we need to integrate with them. So I'm going to show you the real integration from a VM.
Okay.
So where do we get the metrics from or the logs from? From a VM, right? From our own application. So
right.
why do I need to integrate with my performance testing tool? I don't need to. I need to integrate with my application, right? Which I need to monitor.
Yep.
There's no need to integrate with the tool, right? So I would like to monitor the web server, app server, database server, right? These things we integrate. So in the live example, I'm going to integrate one of the servers. And then you will understand that how do you expand them to multiple servers. I'm going to do it for one server. Integration. Does that answer the question, Manoj?
Yeah. Sorry, I just lost the connection and reconnected. But I think it answered my question in the first half. So yeah, that's all good. Thank you.
Sure. Coming to the Splunk Splunk part. See, I can go ahead, I can go on and I can write 5 tools, but again, we have a limitation on the time. We don't talk about Splunk, but understand one thing. Splunk is for use for the log analysis, and Elastic Stack does a very good job at the log analysis, right? So the both are log analysis management tool, right? So we cover Elastic Stack. We focus on the open source, then the commercial tools. I get question like, why can't we cover Dynatrace, AppDynamics, Datadog, New Relic? We need to also understand how much to cover, right? If we going like that, then we cannot cover other aspects. So we focus on the open source tools and we focus on these 2 tools, not any other tools. But having once you know the generic architecture of any monitoring tool, you can easily learn on your own also. Even the commercial tools are easy to learn because they give as a SaaS service. If you use Dynatrace, go to their website, get 14 days trial. AppDynamics, same thing. Datadog, same thing. Splunk also does the same thing. So we don't talk about the commercial tools here to answer some who are asking the question on the Splunk part. Yeah, Vishnu, go ahead. Vishnu, go
Yeah,
ahead.
Roshan. Hi.
Yeah.
Thanks for the demo. My question is, means if I get this course completed, do I get any certification? And will that help in to get any good job? Means
You get the knowledge. You get the certificate from Isha Training Solutions. You get the certification from them that you have completed this course. More than
yeah, will
anything, you
that
get
be
the. Go ahead. Please ask your
inter-
question.
yeah, will that be any useful in cracking any interviews? Will I get any like yeah, will I get any bit of reputation like?
See, eventually it all boils down to whether you're able to answer questions in the interview or not. Let's say by some certification, your interview, the person who is trying to recruiter, like your recruiter may come to know that you know these skills, but eventually it will boils down to whether you have that skill or not. If I ask couple of questions, let's say when I look at the let's say profile, I don't check whether the person is certified or not. Okay, yeah, it gives a one of a point. Okay, person has learned something, has done the certification, but the person doesn't have knowledge. If cannot answer my couple of questions, I'm not gonna consider the person, right? So you may get some calls based on certification, but also understand that it boils down to whether you're able to answer the question or not. Your certification will not land you with the job.
Means my situation is I have a 1+ years of gap, career gap, and yeah, I believe that if I get this course completed, I can get a good opportunities, good calls. Yeah.
Definitely, you will be able to if you are committing 3 months with me, you are going to
Mhm.
get very good knowledge and you can really apply multiple places for multiple roles, right? And these roles, as I told you, all these 3 roles, depending on your current skill, obviously, and it will help you. So getting the knowledge, yes.
Yeah.
Roshan,
Uh,
Vaibhavi here.
Yeah, go ahead, Ravi.
Yeah, Roshan. So I'm basically from tools and observability background, and how the SRE course is going to help me to enhance my career, because I'm also stuck at some position, right? So where I'm not able to move ahead, and most of the times, right, I'm getting rejected because I don't have SRE background.
Hmm.
So though I have observability, but I don't have SRE background. So how it is going to help me here?
See, you have a very good upper hand that you understand the. I believe you must have been expert in one of the tools, correct? Or at least couple of
Yes,
tools.
I am working on I worked on Dynatrace, AppDynamics, and New Relic.
So that's a very good upper hand that you have. That you know these tools in and that everything about these tools, how to set up, how do you create dashboards, alert, right? You are very much already there. So all you need to know is the real concepts. The how do you troubleshoot an application is what I would see. Troubleshooting, if you add troubleshooting part, right, to your resume, to your skill, that's gonna be very helpful. But to get troubleshooting experience, there's no course as troubleshooting. You should know the background of each and everything, the cloud part, the Docker Kubernetes part, how about microservices. You should know about these things in detail, Java performance engineering part. So then only you would be able to troubleshoot application. So, and that's what you need to focus in your resume, that you are not just an observability setup. You don't just set up things like set up dashboards or alerts. You just don't do that. You can also fix the problem that comes. If you are seeing a high response time, if you see the problem with SLAs of errors, right? Or the CPU memory, any breach of the SLA that you have defined, you cannot just report it, but you can also solve the problem, at least drill down the problem. So that's what the SRE engineer does. They are very good at troubleshooting. They understand the problem and they point to the right team. And if it infrastructure problem, they fix it. So you need to have the thorough knowledge on the cloud. You need to have thorough understanding of the Linux systems so that you can go inside and do something. You should know thorough understanding of microservice applications, containers part, and the Java performance engineering part. These tools, these things will help you. The databases part, obviously, these things will help you in developing the troubleshooting skill. And that's what you need to focus on to add it in your skill. And that's when you can showcase yourself as the SRE engineer.
Yeah, thanks, Roshan. And I hope this course will help me to enhance because that is
Right.
what I'm looking for right now.
Right.
Yeah.
Right. That's what we are focusing on in this course. Yes.
Okay. Thank you.
Sure.
Hey, hi, Roshan.
Great.
Karthik
Yeah.
here.
Mhm.
Roshan, actually, I'm having a background of a performance engineer. So, if I want to become an SRE, right, do we require any kind of a programming skills as a
You
prerequisite?
need to have a scripting, because see, as an SRE engineer, right, your role is on the production. Okay. And in production, sometimes you need to automate stuff. I'm not saying that you need to have a developer like of knowledge of programming, no, but you need to have that, I would say, the automation mindset. Okay. Because if you're doing the same activity, let's say I'm just giving one example. Let's say customer needs some detail from prod. Let's say they need some detail, or you need to run a job. You need to do some activity in the prod, right? To do some activity, or you need to take a snapshot. I'm giving a couple of examples. Let's take a snapshot, or you need to update something on the databases. So you should know how to get these things automated. So I'm
Okay.
going to share some 20-30 scenarios which is most frequently used. And with that, you should be able to take up the Python scripting part, at least the
Okay.
mindset. Get some basics Python and then use AI tools to upskill that. That's what you should do.
Okay. Got it. Okay. And one more thing, these courses are offered in any weekends or only on the weekdays?
Weekends batch is going on. They are already
Okay.
30-40% covered. So it will be starting in next 2 months. It's been just, yeah, the batch is there right now going on Saturday, Sunday, but it's already started. I'm coming up with this new batch on the weekdays, 8 a.m. to 9 a.m. Yeah, 3 days a week.
Okay.
Do we also have batch on weekend?
As I told you, right now, no, because that batch is already running. I would need another 2 months to complete the batch and to start a new batch.
Okay. Got it.
Hi, Roshan, Manoj again.
Yeah.
Uh, yeah. So following this course, how can we place ourselves in the market, like at an entry level or
First of all, what is your background, Manoj? If you could help me, then only I can answer you. Yeah.
I'm a performance tester, transitioning into a performance engineer role.
Okay. How much experience you have?
I have 10 years experience.
Sure. So you should try to showcase as a cloud performance engineer that you have worked on cloud, you have worked on Kubernetes, you have worked on Docker, you know automation, right? As a cloud performance engineer, you should focus on as a 10 years experience.
Okay. Okay. And how about taking up the SRE, because I'm more inclined towards SRE. So
Okay,
that
you
actually
can take
excites
up. As I
me.
told you, 70% role is the same. As I told you, you need
Mhm,
to upskill yourself in the some automation part,
mhm.
into the Terraform part, observability part. You need to have more details. So if you add these skills in your current skill that you have, you'll be able to achieve that.
Okay. And with the given experience you have working in this stuff with SRE particular, do you mind commenting on the remote roles that we usually have for SRE? Like how good it is, or
No,
is it
not
very rare to
not
find the?
nowadays. People, everybody's coming calling to office now, right? 3 days they have made it mandatory.
Mhm.
They are calling it. Even I go to 3 days nowadays. So like earlier I
Okay.
used to do work from home, but nowadays everybody is calling 3 days.
Okay. All right. Thank you.
So you can
Yeah, so
find. Having
one
said this,
question.
go ahead.
Yeah,
Go
hi
ahead.
Roshan.
Go ahead.
So yeah, so when we are saying hands-on, so how does the class go on? I mean, while you are doing, we also try to do so that if we get stuck somewhere, you try to help
If I
us.
do that
Or
right, I can do it for initial couple of sessions, but not for everything. If I because let's say 15 people joining, and if we are doing that right, okay, do this along with me, we'll be stuck on only one topic. Hands on, when I say I'm going to do things, I'm going to do the real stuff. You can watch it for now. If you can maintain the speed, you can have two screens, you can maintain the speed. But think about it. If I wait for everybody to complete the hands-on part, this course can go for 6 months also.
so how does the clarification? I mean, maybe today if you uh, uh, say so, maybe after 2 days or 3 days when we
Oh, you
try
can
out.
ask me question any day. I'll be in WhatsApp group with you. You can ask me after 1 hour. We'll be giving
Even
you
after
record.
the class, I mean, this session is complete, we can reach out to you for any doubts, or
Correct.
how is
That's
it?
what I'm saying. That's what I'm saying. So once the session is completed, we'll be sharing the recorded session with you on the same day. Let's say 8 a.m. to 9 a.m. By 12 o'clock or 1 o'clock, you will get the recording with you. You have that time. And that's why we are not meeting every day, right? We are having 1 day gap also. You have the time, practice it, ask questions in the WhatsApp if you have. If not, ask me in the next session when we meet next. You can see at your screen. I can
Yeah,
help you with
my
that.
question is after the course. I mean,
Okay,
after the course also, if
you always
Mhm.
have my number. You can WhatsApp me. I may not promise that I can immediately pick up your call and immediately respond to you, but I'll respond. Yeah, I do that.
Okay, yeah, thank you.
Sure. So friends, I have given you the link of this course. You can please go over this link, and we provide as I told you, there are few recorded sessions and also the Linux part, which we initially give. Okay, just let me expand this. So we give this Linux sessions as well. This is the Linux recorded session, and we have the uh, Java performance engineering recorded sessions. These are going to be the recorded sessions that we provide. And apart from this, everything is hands-on. Everything is hands-on. At the SRE part, let's say we have the hands-on. There are a few batches. Let's say if I just show you, I'll just show you a couple of batches which have just been going on. I'll just show you my WhatsApp. There are a few sessions which are just, let's say this course just completing. We are just completed with this course, 7:30 morning time course. And look at the recorded session that I have provided here. This is going to be the recorded sessions. This batch had just completed. We started on around 23rd June, and this batch has completed till 14th September. So we cover extra topics if you need, we cover. So as you can see here, these are all the hands-on, the live sessions which I cover. These beach batch started on June, so approximately July, August. So yeah, approximately 3 months, right? We have been discussing. So there are 40 sessions around. So this is going to be the live sessions. Along with that, I told you the 2 recorded sessions, the Linux part. And you can ask, these are my earliest to take this, but it again take a lot of time. We'll go for 5 months, 6 months. So we don't want that. 3 months, it's good enough, right? Enough time so that you go over it and ask me any question. Very simple to follow. My recorded session also only. So easy to follow. Just ask me any question. We'll have a detailed lesson. And if you need, no, Roshan, I need some additional session on this. I tried going over, could not understand. Fine, we'll meet. We'll meet and discuss. Right. Along with that, friends, we have a lot of PPTs and books I share. Okay, I share to all of the learners that get enrolled with me. So I have this thing I share. So if you can see this, so a lot of good content here. PPTs for each topic: cloud, Docker, Kubernetes, the Linux part, the SRE module where we talk about databases, DevOps, SRE, right? Java performance engineering, where we talk about, and I share a lot of books, which are important books, uh, where we talk about memory management, Java performance engineering. So a lot of things we share, like very good content to keep you occupied for the next 4 to 5 months, right? I'll talk more about this, friends. I don't have a lot of time today. I will talk more about this on Friday. Feel free to attend on Friday. We'll meet on day 1. I'll take up more your questions on Friday. Okay. So that's all, friends, for today. Thank you so much, everybody. Any questions? Last question, I can take it up for you.
Hi Roshan, Sairam here. So will the session recordings be shared after the class for the reference?
Right. We do share recorded sessions. Yes. Like the one, right? I was showing you, right? This is the demo session.
Not for demo. After once the course is started, right? So those classes.
That's what I'm showing you, the same thing that we are recording right now. We are recording demo. As I said, then day 1, day 2, day 3, same thing we'll be sharing like this.
Okay, got it. Yeah, thank you.
Sure. Thank you so much, everybody. Any other questions?
Thanks,
I see again one person raising the hand. Any other class questions?
Yeah, hi Roshan. How many months course duration?
3 months.
3 months. Okay. And the 3 months cover all the topic, whatever you told.
Exactly. This link. Exactly. This link.
Okay. Actually, I have experience on performance testing, and I have knowledge on the monitoring, and I did that, and I have gap on 1.5 year. Now I'm started searching on job. So is it helpful for me?
Definitely, right? Just a performance, like if you know a tool, that will not help you nowadays. You should know cloud, you should know Docker, Kubernetes, you should know performance engineering. Then only you would be, because everybody's upskilling. If you just think, if you know Jmeter, you can get a job. Yeah, as a fresher, you can. But after certain experience, very difficult. You need to upskill yourself. Yeah. And that's what this course will help you in getting upskill yourself.
So not 7:30. What are the other timings?
No, only 8 a.m. 8 a.m. to 9 a.m. IST. No other time.
No other timings.
Yeah. This is what this timing up it. I myself find difficult to getting a lot of time available. That's the only time that we are coming up with right now. Yeah.
Yeah,
this
that's fine. But 8 a.m. to 9 a.m. little bit tough. That's why I'm asking.
Sure, but yeah, this is the time I could provide for this. Yeah, that's the only time I have. So we can only get it this time. If you miss 10, 15 minutes, let's say you want to leave at 8:45, you can watch 15 minutes recording later also, right? So. Okay, thank you so much, everybody. We'll meet everybody on Friday and we'll take up the day 1 session. Thank you so much, everybody.
Thank you.
Thank you.